Hey guys, in this video we are going to be talking about determining the number of solutions that a linear function has. So we're going to dive right into it here by talking about these three functions. So all we need to do is solve each one. So we'll call this one problem A. So problem A is 7x plus 12 equals negative 4x plus 78. Now remember, your goal when you have variables on both sides is to get all your variables on one side and all your constants on the other. I prefer to have my variables on the left-hand side, so I'm going to move this negative 4x over and join the 7x, and I do that by opposite operations. So I'm going to add 4x to both sides. That will make that 0. 7x and 4x is 11x. Then I have a plus 12 equals 78. Then I need to get my constants over onto the right side. So opposite operation would be to subtract the 12. That makes that 0, leaving me with 11x on the right side. And 78 minus 12 is 66. Then finally, the last step would be to divide both sides by 11. And I get x equals 6. So the solution for the first problem is 6. Let's take a look at the second one. We'll call this one problem B. So B is 6 times x minus 5 equals 2 times 10 plus 3. This is supposed to be an x. Okay. So I see parentheses on both sides. I'm going to go ahead and distribute the terms that are in front. That means to multiply. So 6 times x is 6x. 6 times negative 5 is negative 30. 2 times 10 is 20. And 2 times 3x is 6x. Once again, we have variables on both sides, so I'm going to get my x's over to the left. This 6x is positive, and the opposite is to subtract it. But when I do that, you might notice that this is 0, but so is this. So that leaves me with negative 30 equals 20, which is not a true statement. So what that means is there's not a single x that I could use in this situation that would make this equation true. When that happens, that means there is no solution to the equation. So I'm just going to write no solution, and that is my answer. All right, the final problem on this page, we're going to call problem C. So that one is 7x plus 5 times x minus 1 equals 12x minus 5. There's distribution on the left side, so we're going to take care of that first. The 7x is not being distributed, so I'm just going to bring it down. So 5 times x will give me 5x. And 5 times negative 1 is negative 5. Nothing changes on the right. So 12x minus 5. Now on the left side, I notice that I have like terms, so I'm going to combine them together. 7x and 5x makes 12x minus 5 equals 12x minus 5. Now you might notice they're exactly the same here, which means something, but I'm going to go ahead and move this 12x over to that side anyways, so that you can truly see what's going on here. So 12x minus 12x in both cases is 0, leaving me with negative 5 equals negative 5. Now this time that is a true statement. So what that means is there are infinite number of numbers that I could use for my x value, and that will make this equation true. Literally any x I can think of will make this true. And when that happens, we call that infinitely many solutions, IMS. I should have written that out. Infinitely many solutions. In this case, you could also say all real numbers because every single real number will work. So we could also say all real numbers. This is also something called the identity. All of these mean the same thing. All right, so let's try a few more. For each of these, you are supposed to determine if it's one, infinite, or no solution. Okay, so this first problem here we'll call problem A. So we have 8 times x plus 6 equals 5x plus 3 times x plus 16. Let's do the distribution. 8 times x is 8x. 8 times 6 is 48. Then I have a 5x. A 3 times x is a 3x. And 3 times 16 is 48. All right. I got to combine like terms, so I still have 8x plus 48 on this side. And then 5x plus 3x is 8x plus 48. At this point, I see that they are the same, so I don't have to go any further. You can if you would like to, but you don't need to. So this answer here is infinitely many solutions, or IMS. All right, we'll call this problem B here. I'll move up a little bit. So this one is 5x plus 5 equals 3 times 5x minus 4, and then a minus 10x on the outside. So let's do the distribution. We still have 5x plus 5 on the left. And then over here we have 15x minus 12, and then a minus 10x. We have some like terms over here, so we're going to put them together. The left side once again stays the same. So 15x minus 10x is 5x minus 12. Now here, notice that we have 5x on both sides. So what's going to happen when I move those over to the left is they're going to eliminate, leaving me with 5 and negative 12, which is not true. So if you realize that right away, you don't have to go any further, and you can just say the answer is no solution or NS. All right, let's try this third one here. That's 3w plus 2 equals 7w. Now this time I do have variables on both sides, but you might notice that they are not the same. This is a 3w and this is a 7w. So I'm actually going to get a single solution here. When I subtract the 3w, I get 2 equals 4w. And when I divide by 4, be very careful here. This is not 4 divided by 2, it's 2 divided by 4. So that means w is 1/2, not 2. But that would be the solution for that one. All right, next one over here. We'll call this problem D. So this is 1/2 times x plus 6 equals 1/2 x minus 9. All right, so let's do distribution. 1/2 times x is 1/2 x. Half of 6 is 3, and it's equal to 1/2 x minus 9. All right, once again, I have 1/2 x and 1/2 x on both sides, so they're going to end up canceling out. So 3 equals negative 9. That is a false statement, so my answer is no solution. All right, so let's try the next one. Let me get a different color here. So this is problem E. And we have 7 times x plus 9 equals 7x plus 63. So when I distribute, I get 7x plus 63 equals 7x plus 63. And once again, you might notice they're exactly the same on both sides. So that means I'm going to get infinitely many solutions, or IMS. All right, last one. This is problem F. We have 3 times 2x minus 1 minus 7 equals 6x minus 10. All right, let's do the distribution. 3 times 2x is 6x. 3 times negative 1 is negative 3. Bring down your negative 7 equals 6x minus 10. All right, I've got two like terms, so that's negative 3 and negative 7, which makes negative 10. So I have 6x minus 10 equals 6x minus 10. Once again, those are identical. That means I have infinitely many solutions. And that's it. That's how you determine how many solutions an equation has.